I want to talk to you today about not one, but two methods for remote sensing that can be used to improve the maintenance of closed landfills. There are 3,000 closed landfills in the state of Illinois, most of which are owned by government agencies that provide deep pockets for the perpetual care, maintenance, and sometimes remediation for these cemeteries of waste. Now, the pre-1988 philosophy of solid waste disposal was to isolate the waste from the surrounding ecosystem. The earthen cover acts as a roof to prevent meteoric waters from infiltrating. So we want to monitor the landfill covers so that they maintain the integrity of the roof, reduce water infiltration, prevent unwanted leachate generation, and hopefully avoid groundwater contamination. Now there's two types of depressions that can form in an earthen cover. The most common is a sag type depression that forms in response to decomposition of the waste. Second type of depression is a pipe type depression that forms because of the dispersive nature of the soil. A traditional method for finding depressions is a walkover inspection, but we can exploit the vertical exaggeration of stereoscopic aerial photography to find many more depressions. But if you do find a depression, how do you know whether it's retaining moisture and keeping it near the surface where the water can be evaporated, or it's allowing water to infiltrate through the cover and mix with the waste? Well, this is where remote sensing can help. There's two methods I want to talk about, using photointerpretation and thermal infrared imagery to classify landfill depressions, or aerial photography and color infrared photography Now, if you want to use machine processing techniques, you'll want to avoid the visible part of the spectrum, which is kind of a train wreck. Instead, you'd like to use the reflective infrared, which includes where water reflects poorly, dry soils moderately, and vegetation reflects very highly. And by reassigning the visible colors to include the near infrared, you can make a color infrared photograph that will allow you to differentiate the dry versus the moist soils. That's a help. Now, you could also use thermal infrared imagery, which is especially the nighttime imagery, which includes only the emitted radiation, because that comes from the soil's heat capacity, which is related to infiltration. And so we can use temperature alone to differentiate infiltration. Now in this example, you can see this moisture retaining depression appears cool because of evaporation compared with the surrounding ground. But if the freely infiltrating depression has a temperature that's very nearly the same. So by taking samples from digital imagery, comparing the inside of the depression with the outside of the depression, you can get a classification of whether the water is infiltrating or not. Now, on this example of a closed landfill with a radio control airport on it, you can see on the right that the classified depressions show a lot of freely infiltrating depressions. This landfill required a lot of remediation. Now, the second method uses airborne LIDAR and color infrared photography. Now, it's more of an indicative rather than a classification scheme. In this four-color photography, you can see that the color infrared shows the moisture a lot better than the color photography. And the LIDAR of this newly recovered landfill shows that depressions are forming in the cover. If we extract contours of from that LIDAR, we can see an indication where depressions have developed and water is ponded, or and moist areas are occurring in the landfill cover. We can also see other depressions where water is not being ponded. That would be areas that you'd want to go out and do further checking, because those might be the freely infiltrating depressions. So we've talked about two remote sensing methods that can improve post-closure monitoring of earth and landfill covers prevent unwanted leachate generation, and avoid groundwater contamination. Why wouldn't you want to use this? Thank you.